Today we're going to continue talking about trigonometry, but we're going to apply it to angles of elevation and depression, which show us real-life applications of trigonometry. Now, an angle of elevation is when someone is looking and their line of sight is above the horizontal line. An angle of depression is when you're looking and your line of sight is below the horizontal line. And we can look at that. The nice thing is that because of angles of elevation and angles of depression are parallel, we can use alternating interior angle theorem right here to figure out those angles as well. So, first one, example one. Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So here's the picture, 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5 feet tall, how far is she from the castle to the nearest foot? Now, here's what we have to start with. Before I can do anything, I notice that Leah is 5.5 feet tall, and the castle itself is 190 feet tall. So we have to take into account that 5.5 feet. So I have to take the 190 feet the castle is, minus the 5.5 feet that Leah is, to actually find that this side of the triangle right here, I'll draw it in yellow so you can see it a little bit better, is actually 184.5 feet. Okay? So now that I know that, okay, and I know that the angle of elevation is 38, I can use that to see how far she is from the castle to the nearest foot. And that's going to be this side right here. So I see I have an angle. I know the opposite side, but I'm looking for the adjacent side. So we have to remember which one of my trig ratios was opposite over adjacent. Well, that would be tangent. So we can fill in our numbers. Tangent of 38 degrees is going to be equal to 184.5. Remember, we got that as the 190 minus the 5.5 over x. Now, these were the tricky ones to solve. We had to multiply both sides by x first. And so we got x times the tangent of 38 degrees is equal to 184.5. Now, divide both sides by the tangent of 38 degrees. And I find out that my missing side x is, I go to my calculator and do 184.5 divided by the tangent of 38 degrees, and I find it to be 236 point, or actually it says to the nearest foot, so 236 feet. There's my answer, 236 feet from the castle. Here's an example of a guided practice problem using a football field. Try this one now. Example 2, angle of depression. So first we talked about angle of elevation, now we talked about angle of depression. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to the other person is 42 degrees, and the helicopter is 18 feet above the water, what is the horizontal distance from the rescue to the person to the nearest foot? So essentially what we're looking for, we have angle of depression is 42 degrees. Now, again, because our horizontal lines are parallel, we can find it to be 42 degrees right here using the alternating interior angle theorem. We also know its opposite side, and now it said that they want the horizontal distance from the rescuer, so this distance right here. So again, I know an angle, I know the opposite side, and I'm looking for the adjacent. So that again is tangent. The tangent of 42 degrees is equal to 18 feet over x. Multiply by x on both of them. So I get x times the tangent of 42 degrees is equal to 18. Divide both sides by tangent 42. And I find that x is equal to, I go to my calculator, 18 divided by the tangent of 42 degrees. I find it to the nearest foot is going to be about 20 feet. It's actually 19.99, but rounding that would be about 20 feet. Here's another guided practice problem using the lifeguard. Example 3. It says, to estimate the height of a tree she wants to remove, Mrs. Long sights the tree's top at an angle of 70 degrees elevation. Then she steps back 10 meters and sights the top of the tree at 26. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree to the nearest meter? So let's first look at the small triangle. My angle of elevation is 70 degrees. I am looking for both the opposite and adjacent side. So what we can say is that tangent of 70 degrees is going to be equal to x over y. So what I'm going to do then is I'm going to say, okay, well, let's solve this for x. Multiply both sides by y, and I find that x is equal to y times the tangent of 70 degrees. Okay? Now that might seem like kind of counterproductive because we haven't really got an answer yet. But if we look at the other equation, we get our angle of elevation is 26, opposite over adjacent. So then I'd say tangent of 26 degrees is going to be equal to opposite, which is x, over 10 plus y, because there's this 10 plus the other y. So what I can do is I can multiply both sides by 10 plus y. And I find that x is equal to 10. So let's see, 10 times tangent 26. So 10 tangent 26. And plus y times tangent of 26. So y tangent of 26. Okay? So now essentially what I've done is I've found that this x is equal to this, and this x is equal to this. So if they're both equal to x, that means that they're equal to the same thing, which means they're equal to each other. So we're going to set them equal to each other and solve for y. So I'd say 10 tangent of 26 degrees, which again is just a number, plus y tangent of 26 is going to be equal to y tangent of 70. So again, this is just like a moron problem. Think about it. Are both of the y's have to be on the same side. So I'm going to subtract y tangent of 26 from both sides. Okay? So if you think of it, y tangent of 70 minus y tangent of 26, those are just numbers again. So we get 10 tangent of 26 is equal to, well, both of them have a y in it. So what I'm going to do is I'm going to say y times this minus this. Because again, tangent of 70 and tangent of 26 are just numbers. Okay? So then what I can do is I can say, okay, well, if I want y by itself, and it's y times all of this stuff right here. The way to undo that is to divide it all. So tangent of 70 minus tangent of 26. And I divide this one over here. Tangent of 70 minus tangent of 26. Now I'm going to suggest what you do is pause the video here and try to input this into your calculator. And tell me what you end up getting for y. Now, I just put it into my calculator, making sure that I used all the parentheses correctly. I ended up getting 2.16. So that's 2.16. So now, if I know that that's what y is, okay, 2.16 right here, I can use that information to figure out what x is in this equation right here. So I input to figure out x, I put 2.16 times the tangent of 70 degrees. And so I do 2.16 times tangent of 70 degrees. And I find x to be 5.9. X is equal to 5.9. So that x right here is 5.9. Now the thing that we didn't take into account is the 1.7 right here, right? So what I can do is I could say 5.9 plus the 1.7 height that Mrs. Long is is about 7.6 meters. So the height of the tree, how tall is the tree to the nearest meter? 7.6 rounded would be a total of 8 meters. Now, to be quite honest, this is a more difficult problem. And you probably won't see as many elevation and depression problems this difficult, but I wanted to make sure you've seen a problem with this intensity.